Hello dear learners, welcome you all. Our today's topic of discussion is Newton's forward interpolation formula. Before to study Newton's forward interpolation formula, learners must know the basic mathematical operations, knowledge of finite differences and knowledge of forward difference operator and shift operator. At the end of this session, the learners will be able to derive Newton's forward interpolation formula, and they will also be able to evaluate the value of y at any value of x near the beginning of the given data. In numerical methods, interpolation is the most useful technique. It is an art of calculating values between the tabular values, and interpolation formulas are used to derive formulas for numerical differentiation and integration. Let us understand the meaning of interpolation and extrapolation with the help of an example. Here in the present case, y is a function of x. When x is equal to 4, value of y is 750. When x is equal to 8, value of y is 190. Now, the interpolation is the process to calculate the value of y in between the interval of x, that is, to calculate the value of y at any point in between 4 and 8, and on the other hand, extrapolation is the process to calculate y outside of the given interval. It means when x is more than 8 or less than 4 and we are evaluating y, then the process is called extrapolation. Newton's forward interpolation formula. This formula is used for interpolating the values of y near the beginning of a set of tabulated values of y. Let the function y is equal to fx take the values y0, y1, y2 and so on up to yn corresponding to the equally spaced values of x, and it is required to evaluate y at x near the beginning of the values of x, that is, we are considering x equal to x naught plus ph. P can be negative or positive, and it can be easily evaluated by writing x minus x naught divided by h. It is the value of p. Now, y is at x, which is equal to x naught plus ph. X naught plus ph can be written as e raised to the power p y naught, where e is the shift operator. It means index is p, so this operator will shift y naught to next p steps. That is, we can write y at x naught plus ph in terms of e raised to the power p y naught. And there is a relation in between forward difference operator delta and shift operator e. Delta is equivalent to e minus 1. So we can replace e with 1 plus delta. 1 plus delta raised to the power p, and 1 plus delta raised to the power p, by binomial theorem we can expand it, and you know that the formula of binomial theorem, 1 plus delta raised to the power p is 1 plus delta p plus p into p minus 1 divided by 2 factorial delta 2 and so on, right? So we can write y naught with each of the term. So first term will become y naught p delta y naught p minus 1 divided by 2 factorial delta 2 y naught and so on. This formula is called Newton's forward interpolation formula. Why it is forward interpolation formula? Because in this formula, or this formula contains the forward differences delta y naught, delta 2 y naught, delta 3 y naught and so on. Okay. Let us solve a question with the help of Newton's forward difference formula. For the given data, evaluate y when x equal to 5. Data is x equal to 4, the corresponding value of y is 1. When x equal to 6, y is 3. X equal to 8, y is equal to 8. And when x equal to 10, y is equal to 16. Before to apply the formula, let us construct the forward difference table. You know how to construct the forward difference table? So, in the first column, we will write all the values of x. Second column, all the values of y. And in the next column, we will take the differences of two consecutive values of y. Finite differences. That is 3 minus 1, it will be 2. 8 minus 3, 5. 16 minus 8, 8. And in the next column, we will take the differences of differences, right? That is delta 2y is 5 minus 2, which is 3. 8 minus 5, 3. And in the next column, third order difference, 3 minus 3 is equal to 0. And because we have the initial value of x is 4, differencing interval is 2, because the values of x are equispaced values 2, 4, 6, 8, the differencing interval is 2, and at x equal to 5, y is to be evaluated. These are the values. With the help of these values, we can easily calculate the value of p, which is x minus x naught divided by h. X is equal to 5, x naught equal to 4, h equal to 2, that is 5 minus 4, 1 divided by 2, 0.5. It is the value of p. Now we will use the value of p and the values of y naught, delta y naught, delta 2 y naught, delta 3 y naught. We will use these values in Newton's forward difference formula. Right? So y naught is equal to 1, p is equal to 0.5, delta y naught is equal to 2, delta 2 y naught is equal to 3. So just apply or substitute the values of differences and y naught. We will get the answer, which is equal to 1.625. Means when x is equal to 5, the value of y is equal to 1.625. Let us solve one more question with the help of Newton's forward interpolation formula. For the given data, evaluate the value of the function at 3.5. The given data is x, 3, 4, 5, 6, 7, and the corresponding values of the function fx are 3, 6.6, 15, 22 and 35. So first of all, we will make or construct the forward difference table by writing all the values of x in the first column and values of y in the second column. In the next column, we will take the differences of two consecutive values of y. 6.6 minus 3, it will come 6.6 minus 3, it will come 3.6, denoted by delta y naught. 15 minus 6.6, it will come as 8.4. 22 minus 15, 7. 35 minus 22 is 13. Similarly, in the next column, which is denoted by delta 2 y naught column, and the values we will get after taking the difference of 8.4 and 3.6, it will be 4.8, next difference minus 1.4, 13 minus 7 is 6, and third order difference and fourth order difference we can do it, right? Here the initial value of x, which is x naught, is equal to 3. The values are at the difference of 1, that is 3, 4, 5, 6 and 7. So differencing interval h is equal to 1, and at x equal to 3.5, y is to be evaluated. So value of x is equal to 3.5. P can be calculated by using the formula x minus x naught divided by h. Again it is coming as 0.5, and Newton's forward difference formula, substitute the values of P, y, delta y naught, delta 2 y naught, delta 3 y naught and up to delta 4 y naught. When we substitute the values, you will get the answer, which is equal to 3.28125. It is the value of the function at 3.5, right? So these are the practice questions you can solve by using Newton's forward interpolation formula. The first question is, for the given data, calculate the value of the function at x equal to 47, and the second question, find the value of function at x equal to 1.5 for the given data. Means for both the questions we will apply Newton's forward difference formula, because in the first question y is to be evaluated at 47, which is the near the first value of x. Similarly, in the second question we have to evaluate y when x is equal to 1.5, which is again near the very first value of the x. For further study and practice, you can refer the mentioned books. Thank you for your patience. Have a great learning.